Good morning. Thank you, everybody, for coming. I sincerely apologize for the failure in planning with this rain and cold weather. We really tried, but the coldest week of the year is exactly this year, apparently. But as I promised in one of my emails, we'll keep you warm here with hot discussions. So I want to first thank the Institute of Advanced Studies for a wonderful semester of hosting the research group called Deconstructing and Reconstructing Consciousness. The members of the group were Lucia Meloni, Daphna Shohami, Mike Shadlen. Where is Mike? You should be sitting here. Mike Shadlen, Rafi Malach, Ran Hassin, and myself. And we spent 5 months of intensive discussions with a few other guests, Lionel Nakash, now Tuchia, Timo Stein, and Norbert Schwartz, who came for some time. And this was like amazing experience. I recommend to each of you, if you ever can be one of these groups, please do yourself the favor and do it. So the people behind this are Iris and Yitzhak, who are running the institute, Anat, and her other colleagues who are wonderful organizers, and they are actually responsible for all the logistics of this conference. I'm really indebted to them. It has really been a wonderful way of organizing a program. We just said we are going to have a conference, and they did the rest. Okay, so it's fantastic. We also have to thank especially Michael for organizing the live streaming to the other room. We expect more guests after following the rain. And we have a spillover room, and it's all broadcast in YouTube. And also Yossi, who's not here, but you should convey our thanks for him for taking care of all the hot water problems, heating, and very important things for our well-being during this time. Last but not least, I want to thank Gal. Where is Gal? Who was our research assistant and kept us going and kept this whole thing really working. And finally, I want to tell you what Gal asked me to tell you is that we have a hashtag for Twitter. If somebody really feels like conveying to the world what is going on here, the hashtag is DecRecCon. Like Deconstructing, Reconstructing Consciousness. DecRecCon hashtag. And please use it. And now I want to invite Yitzhak Chen, the head of the institute, to say a few words.
Welcome to Jerusalem and to the Israel Institute for Advanced Studies. I'll tell you a bit about the institute before I'll leave you to your conscious discussions. The institute was founded in 1975, so it is one of the earliest institutes of advanced studies around the world, apart from Princeton, which was founded in the 1930s as a safe haven mainly for scholars who came over from fascist and Nazi Europe. The idea behind the institute here was again to create a safe haven for scholars who wanted to work in groups and to promote their own research and develop and advance new fields or create new fields in their own small sphere. And ever since its foundation, our institute hosted more than 150 research groups and over 2,000 scholars. So this is the main activity of our institute, and the group that really originated this conference was, I should say, one of the most successful ones. We've seen them. They were very active, and we encourage that. This is the main activity of the institute. Apart from that, we are hosting advanced school for PhD students from all over the world. We have 6 of these in various topics each year. And of course, conferences which are related to our research groups. And this is the conference you are here today. I'm not a psychologist, although I have 2 degrees in psychology from the Hebrew University. But in a conscientious decision, I've decided to become a medievalist, and I'm studying early medieval history. So I can tell you that the notion of conscious was first raised by a guy called Macrobius Ambrosius Theodosius at the beginning of the 5th century. And he was actually trying to look at what the various states of consciousness when people are making decisions. So of course you can see here his diagrams of how what are the processes that influence consciousness. The things are rather different from what you are looking for, because he has the stars and the earth and the elements and things like that as things that are influencing consciousness. And you can see this is one of the charts that according to which, if you analyze it properly, you can, according to his theory, you can see what decision people will make. So that's more than 1,500 years ago. You have a different notion of consciousness, and all that is left for me to do is to welcome you to the Institute and wish you a fruitful discussion today. Thanks.
Just a few technical points. So we have tonight a reception at the end of the day here downstairs, right? Downstairs at the institute. I welcome everybody to join us for this reception. For lunch, there are a few cafeterias just next door to here, so you can find your favorite food. We're happy to help you find these cafeterias. They're all within walking colonnades, so you're covered from the rain on your way to the cafeteria. And other than that, we are going to have now a series of talks. We organized it such that we have 45 minutes for each talk, including the questions, and I encourage the speakers to limit themselves to about 30 minutes of talk and leaving a lot of time for discussion. So with that, we start the first session. Rafi will lead it.
Welcome all, and I'm pleased to open the first session. I will give a ring at 25 minutes just to give the speaker an idea of the time goes by. So I'm pleased to invite the first speaker, Professor Orly Shenker from the Hebrew University. And the title of her talk is the Mind in the Brain According to Contemporary Neuroscience?
The microphone. Can anyone help me to put my slides instead of these ones?
This is you attached to your. Okay. That means you cannot move away from this.
This is it?
Yeah. It's not on yet. Okay, good. Let me start by, apart from thanking the organizers for inviting me here, let me say that I'm a philosopher, and so it takes a huge amount of chutzpah to come here and tell this audience something about contemporary neuroscience. So please indulge me for this chutzpah, because I'm really going for it. First of all, this work is a joint project with Meir Chemu from the University of Haifa. And when we're talking about the mind and the brain, for us the mind is everything that is mental, where I'm not distinguishing between sensations, thoughts, etc. All of those are the mind. And when I'm talking about the brain, I don't care about the limits, the physical or physiological limits of the system. Anything physical that may be relevant, whatever it is I will call the brain. And so the question is about the connection, the relation between the mind and the brain, broadly speaking. And in traditional philosophy as well as science, as well as contemporary philosophy and science, there are three major families of ideas about this connection. One is what here I call reductive type identity physicalism, by which I mean the mind just is the brain, mind, mental states and mental processes just are brain states and brain processes. The second view, or the second family of views, is mind-brain dualism, according to which there is something in the world, there are some facts in the world that are above and beyond the brain, whatever the nature of these facts may be. As long as they are not purely physical, they are something else. This I will call dualism, and we will see examples later on. The third family of views, which is, I think, the most prevalent, the very popular, the dominant view nowadays in philosophy as well as in science, is varieties of so-called non-reductive physicalism. Non-reductive physicalism are all the approaches that allow for multiple realization of mental states and processes by brain states and processes. And I will explain very briefly what that means in a minute. In this family, we include functionalism, both computational functionalism and causal functionalism, where computational functionalism is what is by and large done in computational neuroscience. So this is a major topic. This field of research is a major topic of this talk. Here, when I talk about computational neuroscience and computational functionalism in general, what I mean is that the idea that mental processes are identified with computations. I'm not talking about computerized simulations, etc. Simulation is something else. This is an identification. The computation is mental, is the mental. Functionalism is a very complex view. I'm not going to explain all its aspects, but I am going to ask two questions about functionalism, and I will focus on computational functionalism, but whatever I say applies also for causal functionalism. Causal functionalism is, for example, the view that is applied when people talk about genuine neural plasticity, that the same mental state or process is implemented by two different physical states of the world. But I'm not going to talk about the causal functionalism, but only about computational functionalism, just to be more brief. So two questions can be asked. If functionalism says, computational functionalism tells us that different systems, for example, human brain, octopus brain, and the computer motherboard, can implement this, in principle, the same computation, and we're looking at brain processes as being computations, then we should ask two questions. The first question is, which computation does the brain realize or implement, and which physical facts fix this computation? So when we look at a physiological brain, the question is, what is it doing in terms of computation? Of course, the same question will apply for the octopus and the computer motherboard. The second question is this. Since we have here, in this example, three physically or physiologically systems, we should ask what makes them a kind, in virtue of what are they implementation of the same mental state. So in virtue of which physical facts in particular do all these cases realize or implement the same computation. And I emphasize that I'm interested in the physical facts in both questions, because the question is whether the approaches that are under the heading of computationalism or functionalism more general are physical approaches. Are they one of the physicalist approaches or dualist approaches or something else? Now, in this something else, instead of a drawing, I put a question mark, The reason is that it's impossible to draw this approach. And why? The reason is, very briefly, the drawing is a model, and model is a proof of consistency. And this approach is inconsistent. This is why we cannot draw it. So let's go into the detail. So problem 1, which computation? The problem of multiple computations or multiple causations. Which computation? There is a theorem, a well-known theorem proven by Putnam already in the 60s and still discussed extensively in philosophy of cognitive science, which is that the same physical process implements several computations, and there is no matter of fact as to which of those is actually taking place. Either all of them or none of them takes place. I will not go into this in order to save time, but will very briefly present in outline. I will not go into all these details here. Very briefly present this idea by an example. The example is following Orly Shenker's paper from 2012. So, a computation, a physical implementation of a computation consists of a physical system that follows the microphysical evolution, the microphysical trajectory according to the laws of nature. And this is one element of a computation. The second is a way to ascribe values, in particular 0 and 1, to this system, so that as the system evolves according to the laws of nature, the zeros and ones change and we seem to follow a computation, a physical implementation of the computation. So we need the dynamics, the value assignment, and together we have a computation. So here is an example of a dynamics. Without details, you can look at it this way. The A and B elements that go, I can't move with this mic. There is maybe, if this works, it will be helpful.
Turn it on.
Yeah, where's, yes, on. Never mind. So there is this gate, A, B leads to D, okay? And B are the input, D is the output. So here, A and B, the blue, the states, the microstates depicted by blue here, evolve to the blue out there. Thank you very much. Thanks. Okay, so the blue here evolves dynamically to the blue here. The orange here evolves to the orange here along D, and the yellows in A and B evolve to the yellows here. This is a graphical depiction of a dynamical law that follows the laws of physics. This is the dynamics. Now, this is not enough to bring about a computation. For this, we need value assignment. We need to be able to interpret the A, B, and D, these elements, as zeros and ones. So we need to assign to the different values. Each of the elements, A, B, and D, can have 3 different physical states, X, Y, and Z. We need to assign the bits, the zeros and ones, to the physical states, X, Y, and Z. So we can call X 0 and Y and Z 1, or we call Y 0 and X and Z 1, etc. This is, to a large extent, arbitrary. So here are examples. The value assignment 1 will be that X is assigned the value 0 and Y or Z are 1, and another value assignment is that X or Y are 0 and Z is 1. And we can assign different values in the same manner. Now, to follow the computation, we need to follow the dynamics given the value assignment. Together, this will yield a computation. And in this particular example, the result is this. I'm not going to go into this. I will only point out the following facts. If we take the physical evolution from A, B, and D, according to all the options are here according to the physical dynamical evolution that was depicted before. And we assign the values in the two different ways. So there are these 0s and 1s are according to the value assignments given here. Now, it turns out that this particular dynamics with these particular value assignments are such that given one value assignment, the computation is of the function end. And given the other value assignment, the computation is of the function or, with the same, exactly the same microdynamics. So we have a multiple computation by the same microdynamical process given two value assignments. Why should we care about this? Well, this often worries people in cognitive science, people who take the computational view of the mind seriously, because many people think that this might entail that the brain has two minds. If the mind or the consciousness at a given moment, however you prefer to see it, if the consciousness at a given time is given by a computation, is identified with a computation, then we have here two consciousnesses or two minds, two full minds, not a parallel computation, not multiple of minds that coexist in the brain. But whatever you take the entirety of mental things to happen in the brain, you have here two of those. So the problem is sometimes called the multiple minds problem. And the question is, which physical fact fixes the value assignment so that we can say that our mind at a given moment calculates or rather than and, or the other way around. And the solution that is quite easily given, at least easily prima facie, is that the distinction between the value assignments is the distinction between the sensitivities of two different measuring devices. Measuring devices can be sensitive to the, not sensitive to the distinction, for example, between Z and Y, but are sensitive to the distinction between Z or Y and X. And another measuring device will have a different sensitivity. It will not distinguish between Y and X values, but will distinguish between Y or X and Z. And so two different measuring devices will see, as it were, the same system in two different ways. And so for each of those measuring devices, the same system will look differently. It will look as if it implements a different computation. This is a perfectly physical account. Tell me the measuring device with which you're looking at the system. I will tell you the computation that you see the system as carrying out. But now the problem is that we have two measuring devices, and we have to choose between those. And the question is, which is the measuring device that fixes the computation which is our mental state? So two questions arise, or two problems. Problem one, what is the measuring device that measures our brain in such a way that it sees our brains as computing? Because without seeing as computing, without assigning values, we have a microdynamical system. There is no 0 and 1, and there is no computation. So we need something to look at us, to see us as having 0s and 1s in our brain by this coarse-grained perspective. And we need to decide or to find out which thing it is that looks at us. So some people say, well, suppose that in the brain there are two subsystems. The one is the computing system itself, and the other part of the brain is the part that looks at the first one and sees it as computing. Here we should be aware of the homunculus. We should be very careful about that. But put that to the side, go to the second problem. The second problem is this. Suppose that we already decided on a measuring device. Suppose that there is a criterion for choosing a measuring device. I don't think that there is. But suppose that there is. Then the question arises, what does the measuring device measure? Well, measuring devices are macroscopic systems, and those can be seen in light of different macroscopic variables in various coarse-grained ways. This is analogous to the problem of value assignment reapplied to the measuring device. We can look at the same measuring device, assign to it different values, and when we do that, the same device will produce two different measurements. So choosing a measuring device is not enough. We should use, in order to see which is the correct value assignment for the measuring device, we need another measuring device. This leads us to a regress. And the result is that there is no way within physics to assign values to a physical system in order to make it implement a computation. That is impossible. There is a regress. This is not a well-defined notion within physics. What is the solution? The solution is to forget about the computational view of the mind and to replace it with an identity theory. Identity theory, according to which we will find the mental in research of the biology, the physiology, the physics of the brain, and forget about the notion of computation, which is, as I said, not well defined, and maybe even worse than not well defined. So what we have here, the solution for both problems is that the physical aspect of the brain is the mental state. This is reductive type identity physicalism. As long as we are within this view of reductive type identity physicalism, the mental is identity physical. It is physical. It is physics of the brain. It's not about computation. Computation is at best a useful, convenient description of the mental physical aspects of the brain. It's not essential. The mental is not essentially computational. The mental is essentially physical. You can use computational terms if it's convenient, fine, but it's not very important. Unless you do that, unless you proceed, you move to identity, physical, reductive theory, when you're outside of the reductive physicalism, computation is either dualist notion if the regress is stopped in a non-physical way, if you just choose a measuring device by some arbitrary stopping point, you decide, well, this will be my measuring device. There is no physical way of doing that. This will be a dualist move of stopping the regress, or it's not well defined because there is a regress that is not stopped. The result is this. Recall question 1 for functionalism. We ask, which computation does the brain realize or implement, and which physical fact fixes this computation? The solution for problem 1 is this. In computational neuroscience, without identity physicalism, the fixer of which computation is not physical. This is a dualist mind-body view. If you accept this view, then brain research is irrelevant for studying the mental because the mental is not in the physics. The solution is move to reductive physicalism. Here, the mind is the brain or is in the brain, and the physical features of the brain are to be discovered by brain research. But here, as I said, computation is at best a convenient description of the mental physical aspect of the brain. This is end of problem 1 and its solution. Proceed to problem 2, which is the one described below, in virtue of which physical facts do all these cases realize or implement the same computation. This is the problem here is called the problem of multiple realization. Multiple realization is the realization of the same computation by these different physical systems. Okay, here there are two options. One is that the fact that is shared by these three things is a physical fact. They have a physical property in common. But this is reductive type physicalist view. This is not functionalism. This is not multiple realization. This is not the computational theory of the mind. So we don't go for it because we want to study what goes on in the non-physicalist view. So option 2 is this, and this is a very subtle and important point about functionalism and about multiple realization in general. The idea is this. If we don't go for identity physicalism, if we want to allow for multiple realization, genuine multiple realization here, then we have to accept that all these cases, A, B, C, as well as D, which does not carry out the computation, all of them are physically heterogeneous to the same degree. That is, they do not share anything that is relevantly physical. If these three are to some extent similar, then I would say that being to some extent similar is being identical in that extent. So similarity is rough identity, and rough identity is identity of an aspect. So we cannot, if we want to really genuinely accept functionalism, if we want genuinely to accept the computational theory of the mind, we have to assume that in all these cases, there is nothing that is physically relevant that is shared by all these systems. Nothing. And since nothing is shared by them, they are not more heterogeneous than they are heterogeneous relative to something that does not carry out this computation. This heterogeneity is crucial. Without it, you cannot even start the functionalist view. So you have to accept it. Okay, so we go for this. We go for the heterogeneity, physical heterogeneity option. Here, there are two problems or two questions that need to be answered. One, why are physically heterogeneous things implementations of the same computation or the same mental state for that sake? Problem 2, why are A, B, and C the same as far as computation is concerned? Why do A, B, and C implement the same computation and D doesn't? After all, D is as heterogeneous relative to A, B, and C as the three of them are heterogeneous one relative to the other. And this is crucial. Without this, there is no functionalism, as I said. So why A, B, C are of the same kind and D isn't? We have to answer this question if we want to accept functionalism of any sort. Well, one possible response is this. True, A, B, and C are totally physically heterogeneous, but we look at them, and for us, they look the same. Fine. So here is us. So these three eyes are red, this isn't. So to us, these three look the same. For example, we causally interact with these three things in such a way that in us, they make the same impression, whereas the physical interaction with this one creates a different impression. So the shared thing between A, B, and C is us. Actually, what we have here is an extended system. We no longer have brain, octopus, and motherboard. We have brain and observer, octopus and observer, motherboard and observer, extended system. But those extended systems are no longer heterogeneous. They share something, namely the brain of the observer. So the brain of the observer is shared by all these cases, but then heterogeneity is lost. This account is a physicalist account. If you add an observer, you extend the system and you say that the state of the brain of the observer is shared in all these cases. This is not a case of multiple realization. This is a case of identity physicalism, and I'm fine with that. We want heterogeneity. So here, the extended system, what's going here? Yeah. The extended system is not physically heterogeneous. This is not genuine multiple realization. If we want genuine multiple realization, we need the observers to be different as well. So we have three, for it, we have extended systems, fine, but they are heterogeneous, they don't share anything. And then the question reappears. So as long as we add something to the system, as long as we extend the system by adding something physical, an observer, a measuring device, whatever that is, which is not heterogeneous, we're back to identity physicalism. We don't want that. We want genuine multipolarization. We want the computational view of the mind. So the only way to overcome this is to say, well, you know, forget about all these observers and measuring device. The fact that A, B, and C carry out the same computation is just a brute fact. And the term brute fact appears in the literature, in the philosophical literature. But brute facts is non-physical facts put in a nicer, more scientific-looking terms, perhaps. Brute facts, which provide genuine multiple realization, are facts that are not physical, and therefore we do not require them to be physically heterogeneous. They are just brute facts somewhere. They cannot be physical, because if they were physical, we would require them to be heterogeneous. So in order to solve this question of why SEM computation, and if we want to do it in the framework of genuine multiple realization, in order to take very seriously the computational view of the mind, we need to be dualist. And here this is, you know, really substance dualist, perhaps, not perhaps, you know, if some people are happier with property dualism, whatever, it's the same. These are non-physical facts about the world, without which the computational theory of the mind cannot be maintained. To sum up, recall that we had these two questions: which computation, and in virtue of which same computation. Recall the response to problem 1. We said that the fixer of which computation in computational neuroscience is not physical. This is a dualist view, and therefore in this approach the brain research is irrelevant for studying the mental, and I propose replacing this view with identity physicalism. It's nice to discover that the solution for problem 2 is exactly the same. The problem is the same, and the solution is the same. In computational neuroscience, the fixer of shared computation is not physical. This is a dualistic view. And if dualism is the case, then brain research is irrelevant for studying the mental. And again, we propose to replace this functionalist view with type identity reductive physicalism. That is, to carry out brain research not in terms of computation, but in terms of the physics of the brain, the biology of the brain, the physiology of the brain. This is where the mind should be found in a non-dualistic way, a well-defined view. So the answer to the question of is the mind in the brain according to contemporary neuroscience, the question is, it is not in the brain in computational neuroscience and other forms of functionalism that allow for genuine multiple realization. It is in the brain in reductive identity, physical or physiological study of the brain. Thank you very much.
Thanks, Orly. We have time for questions. You can take
Can you give me the water? I can't walk with this. Yeah, thank you. This? Okay, great. Now you tell me. Okay. Rafi, you take what? Yeah. Okay.
So, yeah, you reject functionalism. I mean, I suppose that, well, since Searle, this argument against computational, a full computational explanation of the mind has been around, but the identity theory also has a lot of problems. So if you take identity theory, you would deny mind, let's say there will be aliens, and they will behave like us.
Mm-hmm.
Therefore, you have to, I mean, from a functional perspective, you would say, well, look, they behave very, you know, you can assign to them functional states because they seem to be like avoiding pain and they try
Fine.
to strive for things.
Yeah.
So there are all those computations which you can behaviorally,
Yeah.
I mean, taking like a Turing approach or psychology approach,
Yeah.
you can describe computation to organisms even without getting into their brain,
Well-
just from outside.
Well,
But then you will
yeah.
have to deny that it's possible to understand
Yeah.
minds by any kind of behavioral observation.
That is not the case. So there is bad news and good news. The bad news is that this line of thinking is not open to you if you want to be a physicalist. If you are willing to accept non-physical facts about the world, then this line of thinking is open to you. This is, I call it the bad news. Some people will think these are good news. The good news for the reductive physicalist is that it is perfectly possible, even not very different from what goes on in actual physiological research of the brain, to explain aliens, robots, other minds, and so forth. In fact, reductive physicalism is the only solution to the other minds problem, by the way. So the account for the alien will be the following. Option one, the alien is, let's call it a robot, that mimics our input-output behavior without having a mind at all. This is option one. I don't see why this shouldn't be the case. Option two, the alien does have mental states. In that case, somewhere in its physiology or its environment or what have you, in a distant quasar, there is something that is relevant to the mind of that thing. And the thing which is the mind, is a copy, a precise replication of the thing in physics, which is your mental state. This is an identity theory. There is an aspect of your brain which is your mental state, and this aspect is copied exactly in that thing. Now, copy, I don't mean that it has, the sweatwear that we have. It can be made of anything, but we know from physics that there can be systems that look very differently, but they share a function of their microstate.
So you need some kind of isomorphism, but it...
Copy is much stronger than isomorphism. Copy, a precise replication.
But then it has to be carbon-based.
No, it doesn't, because some features of carbon may be the same as other molecules. So you can have a very different chemical substance that replicates, copies the precise same physical, if you want subatomic, whatever it is, feature, which is your mental state. The idea that in order to have type identity physicalism, you need to have a physiological similarity is an error that was implanted to the literature by Hilary Putnam. This was a great mistake that led philosophy astray for dozens of years. This is mistaken if you look at what physics is, what a physical state is, and you take your lesson from branches of physics, in particular statistical mechanics. So this, from physics, we learned that this is totally mistaken. And what you do in biological, physiological study of the brain is look for that feature of the brain, and if you want, copy it to something else. I'm not against it. Of course, as I said in the beginning, you can opt for the computational view. Fine. If you are willing to accept that there are non-physical facts in the world, fine, go for it. I don't know if we are, yeah, okay, so please. Yeah.
Okay, well, I'm not that big a fan of functionalism either, but of course, given this problem that was just discussed, how are we ever to find out which are these physical facts in, say, in the brain or in any other system, without resorting to any kind of functions that I mean, for example, people saying, I had a conscious sensation of this or not.
Yeah, it's, well, I guess there is still a long way ahead of us, but we can learn from the history of physics. Here is an example. During for millennia, or in at least a few centuries, people talked about heat. And during the 19th century, people developed the thermodynamics of the theory of heat, and they talked about all kinds of options to account for heat, for example, by a substance called caloric and so on. And at some point, people had the idea that heat is nothing above and beyond the basic constituents, that is the particles that they thought the world is made of back then. And they were looking for an aspect of the microstate of the world, which is the heat. And for example, the famous example is for an ideal gas in equilibrium, heat is average kinetic energy of the molecules of the gas. Now, there is nothing in the concept of average kinetic energy of molecules that resemble the intuitive notion of heat. But according to physics, average kinetic energy of the molecule just is the heat. There is nothing, it doesn't give rise to heat. It is heat. And this discovery is highly non-trivial. It was very difficult. Of course, I guess it's much easier than finding the features of the brain. Fine, go to work.
Okay, but we can observe heat.
Yeah.
Observe these molecules and then see the identity.
I do not think so. I think that when you observe heat, the thing that you observe is directly the average kinetic energy of the molecules. You do not observe heat and average kinetic energy of the molecules. When you observe heat, you learned through science that what you observe is actually the average kinetic energy of the molecules. You call it heat, but fine, that's a name. So when we will learn about the brain, that when we talk about sadness, we actually are talking about the brain thing. The brain thing, it does not give rise to the sadness. It just is the same thing. Exactly as in heat, there is no heat above and beyond that thing down there.
So just to clarify, following this heat example, so two elements that have exactly the same heat, will you call them a copy of one another? Because the microstates are very different.
That's right. I will say that the heat is exactly the same. So it's not...
let's say mental state is heat. You will say then the two elements have mental state,
despite
the fact that they have very different...
Yes, they will have identical mental state. It will be the same, indistinguishable, the same thing exactly.
But the microstates are different.
Yes, the other features, some of the microstate is responsible for that mental state, and then it will be an exact copy. The rest of the microstate is irrelevant for that. Fine. Let me go to, okay, yeah.
Can I defend computational neuroscience?
Sure. If you can, you can try. Yeah.
In this business, but I thought I was actually quite happy, my computer stopped up, but I was quite happy with your description of computation as approximate description of what the physical system is doing.
Yeah.
I think that's what we do in science. And I'm a bit surprised you mentioned the heat example, because it's an example of an approximate computational mathematical description of what the physical system is doing.
What, the heat?
Yes, it is a
I disagree.
mathematical description. It is by the mathematician. It's very similar to what we do in computational neuroscience when we describe a computational state.
If it's the same, then I'm happy. Then you're not doing computational neuroscience, but identity theory.
Well, I think we are doing an approximate approximate description by mathematics. But
No.
second, I think you left out something very important for biology, which
Yeah.
is evolution. With evolution, the system of animals approximated better computations. And I think that's why computational neuroscience is so powerful, because there are actually computations that make organisms successful, and these are the ones that were selected. So you look at a predator catching a prey, the computational description is excellent. You have systems in the brain tracking the trajectory, the speed of the prey, and you have systems matching it with the predator and so on.
Yeah.
I think the computational description is much better than you think it is.
First of all, computational description may be very convenient. But then you first of all have to choose which computation is carried out. And this you cannot do unless you opt for identity theory. This is why you have to assume identity theory if you want to use this convenient way. With respect to the evolutionary perspective, I'm more suspicious in the sense that, regardless of the evolution, I want to understand the system as it is now, and selection in order to achieve something is something that is teleological. I'm a bit suspicious about this, but we can talk about this. This is not main here, so we can discuss this later. But it seems to me from what you're saying that this is essentially identity theory. Look, if people here are saying that they are using the computational terminology as a convenient way of describing something that they know is there physically, then I'm fine. I said this may be very convenient, but the selection of which feature, which aspect, what is the value assignment is done not within computationalism. You need to step out of this and opt for identity theory. Then use computation. I'm not against it. It's a nice tool. Who knows where it will take us? But it will not tell us what is the mind, because the thing which is the mind has to be finally at the physics. Rafi, you tell me when to stop. So, yeah.
You have time.
Okay. Yeah. So.
Yeah.
Yeah.
I'm also not a big fan of computationalism, but I have two concerns. First, with regard to the multiple computation problem, I'm not sure if the problem is with computation as much as it is with motherboard analogy. The idea that computation requires fixed gates, right? And the input is dynamic is one thing. It can also be that maybe the complex dynamic system, I don't know, that it's conceivable at least that the gates themselves are part of the input, let's say, or can be.
Sure.
And then there's, I'm not sure how the multiple computation problem arises. And the second thing with regard to
sorry, just so that I don't forget, you're saying that the input is imposed by the environment or something like that?
The input inside, like
what's the input
computational
inside?
process itself, like
Yeah.
whether it does and or for example,
Yeah.
it does depend on the input,
That
or on another input, on the third.
on the value assignment only in my example.
But I'm saying that the gate itself can be part of the value assignment.
This is
Conceivably.
this cannot be the case given the physics that I just described. Whether the gate is an AND gate or OR gate does not depend on the environment nor on the physics of the gate, but only on the value assignment. And the question is where it comes from. So here I have to insist.
And
We need-
just one other. I'm afraid that with the identity theory, it actually makes the whole notion of computation senseless. Because if our brain is, like, if it's identical, and we look at the computer, then
Yeah.
what assigns the value there? Nothing assigns the value there, so it's all just a big mirage.
Fine, I'm fine with that, but I'm not against, whatever works within science. I don't want to tell scientists what to do. If it's convenient, fine, but it's not essential. I'm with you on that.
We need to continue. Thanks for very lively, starting on a good energy.